Throughout most of history, casters used beeswax. Today, petroleum-based waxes are used in its place. Wax used for casting must be strong enough to hold its shape during the finishing process, but workable enough to retouch. The wax shell should be a uniform thickness so the bronze will flow smoothly when it's poured. The sharper edges of the swan mold need to be brushed more carefully to assure an even thickness. What began as a solid sculpture in foam has become a hollow one in wax. The process is continual change and refinement. What was sculpted in the original is retouched in the wax, adding finer detail. For the investment mold to fill the core, the sculpture is separated again. A curved cut assures an accurate fit when the bronze is welded. Now gates and vents must be attached to the waxes. These wax rods will be burned out along with the sculptural wax, leaving channels for the bronze to flow through. The wax cup will become a pouring gate for the bronze. The network will be assembled to stand upside down. This rod is a gate through which the bronze will enter the sculpture. This smaller rod is a vent, which will allow air to escape. Vents must extend to the top of the mold. When turned right side up for pouring, the bronze will flow down through the cup and up through the vent, signaling the mold is filled. High points are vented to keep air pockets from forming. Core nails are inserted through the wax. These will hold the investment core in place when the wax has been burned out. Finally, I check to make sure all the joints are smooth and secure so the bronze can flow freely. The pieces will be invested with cups down, then turned over for pouring the bronze. A metal form is made for each mold. Chicken wire is used as reinforcement. Various mixtures can be used for investment. This is a combination of casting plaster, silica sand, and Ludo. The Ludo is made by crushing old investments into fine powder. Fiberglass adds strength to the molds. The investment must stand up to the heat of the kiln and the pressure generated by molten bronze. It should take fine detail, yet be porous enough to allow gases to escape. If air gets trapped in the mixture, it can form bubbles on the surface of the bronze. A vacuum chamber removes most of the trapped air to minimize these bubbles. The investment is poured in several layers. The wax chimney remains clear to allow the escape of gases during the burnout. A firewall will prevent direct flame from hitting the molds as they're heated in the kiln. Potters were the first masters of fire and likely became the first metalworkers when they discovered residues from ores in their kilns. Fire changed human consciousness. It gave the power to transform clay to pottery, ore to metal, and metal into sculpture and tools. Now fire will burn the wax out of the investment, leaving a final negative mold as a receptacle for the bronze. The flame is adjusted to begin an even buildup of heat. When the temperature reaches 1,000 degrees, I'll keep it there, tending the kiln during the night and most of the next day. By then, the wax will be completely burned out. At the dawn of civilization, metal was a sacred substance. The minute amounts that existed were thought to have ripened naturally from embryonic ores in the earth. As transmuters of the sacred metal, early founders were endowed with demiurgic powers. What the earth could achieve in natural time, they could much faster with fire.